Hello guys and welcome to the third video of Kotlin for Beginners playlist. Today we're going to talk about a couple of stuff like type inference, more in data types, and comments in Kotlin. To start with the type inference, let's define them. So type inference is just a feature of Kotlin that lets Kotlin guess the type of the variable for you instead of setting it explicitly. So as you can see, we have here 6 variables, and for each of the variables we set the type of them explicitly. So for example, name of type string and age of type int. So instead of that, we could let Kotlin do this for us, as setting the type of every variable we make might seem pretty tedious. And also, the IDE would give you a warning telling you that setting the variable type might seem redundant. Now, we could fix this by just deleting the type, and this name now is of type string. Let's just undo what we did and check its type by pressing Ctrl Q. It's type string. Now let's delete this, check its type again, and it's still of type string. You could fix also this by having a shortcut by pressing Alt Enter here, Alt Enter, remove explicit type specification, and do this for the rest of the variables. Notice here that Kotlin gets the type by depending on its value, on the variable's value. So for example, GPA here is of type float because we have the letter F here and it's a floating point number. But what if we delete this F here? Now the GPA becomes a double. So now with the comments. So what are comments? Comments are just a piece of text that you can put along with your code and that the compiler will totally ignore. So before we know the purpose of having them, let's try them. And there are two ways of creating a comment. The first one is called one-line comment, where you can make it with double forward slashes. And as you can see, its color turns to gray. So this is a one-line comment. Let's make another one. This is another one-line comment. But the question here arises, and what you would say, what if I want to make a couple of lines of comments, or for example, a block of comments? Having multiple forward slashes might seem pretty ugly with the code. So here comes the second way of doing that. And the second way is called block of comment. So to make a block of comment, you need to open forward slash asterisk, close it with asterisk and a forward slash. So whatever between these two going to be considered as a comment. So let's try. This is a block of comments. And if you run the code now, nothing will happen, as the compiler will ignore them. Now, you might ask yourself, what's the purpose of having a comment along with your code? So say for example, you have a piece of functionality in your code, my name, and you have a team of developers working on the same project. So having a comment with your code adds some explanation or elaboration for the functionality of this piece of code. So for example, this prints my name. Now we're going to start with learning some new data types that we didn't cover in the last video. I'm going to start with something called array or an array. So arrays are used to store a sequence of elements or sequence of items, and these items can be of any type. So to see them in action, let's make a new array. So I'm going to call it my array is equal to array of. Here you can add the items or the list of items that we wish to store within this array, separated by a comma. So for simplicity, I'm just going to add 100, 50, 25, and 0. Before these parentheses here, you can also specify the type of the elements you stored in this array by adding this diamond bracket here and add the type. But this is redundant since Kotlin has type inference. Now, as you may know, Kotlin is a zero-index language, so whatever collection you're going to use, like arrays, anything that you're going to store in them is going to start at the position of 0. So for example here, 100 is stored at 0 position, 50 is at 1, 25 2, 0 at 3 respectively. So it's important to know their position as we're going to use them when we access these values. Now let's try to access them. Let's try to print them to the console. So I'm going to call myArray.get. And here you can see that get function takes the index or position of the item that you wish to access. So I wish to access the first item, 0. There is another way to do this with the square bracket here. So this line is equivalent to this line. Now let's print other items as well. 2, this is for 3. And here are our items. What if you want to modify some items within this array? There is another function that's called set. So I'm gonna call myArray.set. And here it takes two things. First, the index of the item that you wish to modify, or the position of the item that you wish to modify. So for example, I'm gonna modify the first item, 0 here, and the new value that you wish to assign to this item, so 1000 for example. Now if we were to print this, here's the new value assigned to the item at position of 0. Similarly, we have the same way we can use it to assign new value. So my array at position of 0 is equal to 1000. This is the same as the set method. Now, one thing to note about arrays that they are immutable. So once you set them or once you initialize them, you cannot change them. Yes, you can modify the values or the already stored values, but you cannot delete or remove or add any values. Now, let's check the size of this array. So how many elements does this array have? Obviously, there are 4. But we have a method or a property in Kotlin that checks this for you. So println myArray.size. No, so the size is 4. Now, say for example, you wish to add another item here, but not from the initialization code, but from within anywhere in the code. So I'm just going to add myArray.set. And here I'm going to give it the 4th index or the 4th position. So at the 4th position, put this value, for example 99. Now if you run this, you can see what happened. So what happened is that it gave us an error or exception. It says that index out of bounds for length 4. So you cannot add or remove values from an initialized array. Now with the lists. So they are just like arrays. The only difference is that they are only for reading or read-only types. So once they are initialized, you cannot change their values and add or remove. So just like arrays, but you cannot change the already stored values. So let's try them out. Val lists equal to list of, and have the same values, 100, 50, 25, and 0. Now let's try to print or access any of the values within this list. .get 0, or similarly you could do it with the brackets here. But note that we don't have something, or we don't have the set function here. Now what if we want something more dynamic, something more flexible, something that we can add, remove, and modify items at the same time? We have something called mutable list, and as the name suggests, it's immutable. Let's make a mutable list here. So I'm gonna just call it mlist equal to mutable list of. For the last time, I'm going to have the same values, 100, 50, 25, and 0. Now, let's try to access them again, .get or with the brackets. for example. Now you can add any items at any position or index within this list, and also modify any item within this list. So now let's just try to modify the second item and add a new item at the end of the list. So I'm gonna modify the second item, so mlist dot get set here. So let's modify the second item at the index of 1, give it the value of 100 again. Now let's add a variable or a number at the end of the list. So mlist dot add. Now note that we have two functions for add, one that takes an element and one that takes an index and element. So the first one, if you didn't specify any index, so if you just add 100 here, or why I'm just sticking with 100 today, for example 88, this 88 is going to be automatically added here to the end of the list. But if you want to add something, for example, to a specific index, that you can add your index here, for example 4 and 88, which is going to be the same to add it at the end of the list. Now let's just print this list. So println, I'm gonna print the fourth item, or the item at the index of 4. So mlist dot get, or with the brackets 4. So let's try to make it more readable. From mutable list. So we added this item at the index of 4, and we modified the item, the second item, so 1. Now let's run it and see the result. So here is our element, the first element here, or the element at the index of 1, I mean. So this is the first element. The element at the index of 1 must be 50, but we modified it to be 100, and we added another element at the index of 4, which is in the end here, 4, with the mutable list. Now the last data type that we're going to talk about today is called maps. So maps are slightly different from what we have seen today, because maps stores values as key and a value pairs, or stores elements as key and value pairs. And to visualize this and to make it more clear, we're just going to have a literal example before we see it in action. So say, for example, the key is a name and a value is Astro, and the key is a channel name and the value is Astro's coding. So here's the key and here's the value, here's the key and here's the value. So this is how maps basically works and how it stores values. So to create a map, we're gonna have mutable map. There's just a couple of ways of doing this with the map, which is just like the list, read only. And we have mutable map, so we're going to use this mutable map as it has all the functions in the regular map and some extra functions. Now here we can just specify one type of data, because we have a key and a value. So we should tell the map that our key is of type what and our value is of type what. The way to do this is to have a comma here. So our key is going to be of type string and our value is going to be of type string. You could do this here, or you could specify the values directly here. We're going to see how this works later. So now I'm going to add some values. So map dot here you gotta specify the key. So the name is equal to Astro. Map the channel, not small, channel name equal to Astro's coding. Now if you wish to access these values, have a println statement, println function, and say map. There is no get here, we could just pass the key, so name, and similarly for the channel name. Let's see, it must print Astro and Astro's coding. Yes. So instead of doing this, we could do it here in the mutable map function with this, pretty much the same procedure. So just gonna delete this because we have type inference, and I'm gonna say that the name, set the name key to the Astro value, comma, set the channel name key to the Astro's coding value. And if we run this, we are going to have the same result. And let's have another way of putting values. So instead of doing this, yes, we have a function called put. So map.put. Here we also specify the key and the type in the same function. So the name is Astro, and the channel name is Astro's coding. Run it again to have the same result. And here it is. So this is all for today's video. I know it has been a long video, but we had to cover the collections data types like arrays, lists, and maps. And in this next videos, we're going to discuss more about this beautiful language. Till next time, stay tuned.